Dear students, in this video we are going to learn about the concept of polynomial regression model and logistic regression model. Coming to polynomial regression model, it is the extension of the simple linear model by adding extra predictors obtained by raising each of the original predictor to a power. That is, if x term is there, we add x power 1, x power 2, x power 3 like that to the function. F of x is equal to c0 plus c1x plus c2x square, c3x square, where c terms are called as coefficients and x terms are called as predictors. This approach provides a simple way to yield a nonlinear fit to data. Consider a table of internal and external marks consisting of 15 samples, and we want to plot this the relation between these internal marks and external marks by using a polynomial with degree 3. We observe that the regression line is slightly curved in this case because we are using a polynomial with degree 3. So generally, if you increase the degree of the polynomial, the curveness of the line will also increases. So as you increase the degrees, the curve will also further increase. So in this diagram, we are having a regression of polynomial regression with degree 14. So generally, when you choose the degree with highest degree, there is a possibility of overheating at the extreme values of the data. So here in this example also, some of the values will be overfitted because of the larger degree polynomial. So therefore, choosing the appropriate degree for fitting the given data is most important in polynomial regression. So coming to the logistic regression technique is used both for classification and regression based on the scenario used. Logistic regression is also called as logit regression. It is a type of regression analysis used for predicting the outcome of a categorical dependent variable, similar to ordinary least square regression. In logistic regression, dependent variable y is binary in nature and independent variable is continuous in nature. That means the dependent variable y is binary. It is either 0 or 1. Independent variables are continuous in nature. The probabilities describing the possible outcomes, that is y is equal to 1 or 0, of a single trial are modeled as a logistic function of the predictor variables. So generally, logistic regression is used to model those problems where we have a single trial. In logistic regression model, there is no R-square model to test the overall fitness of the model. We use chi-square test in order to find how well the logistic regression is fitting the given data. The goal of the logistic regression is to predict the likelihood that y is equal to 1 given certain value of x. So that is, if x and y have a strong positive linear relationship, then the probability that a person will have a score of y is equal to 1 will increases as the value of x increases. That means if x and y are having strong linear relationship, then probability of y is equal to 1 will increases with the value of x increases. So we are predicting probabilities in logistic regression rather than the score of the dependent variable. For example, we want to predict the success of a project based on the parameter, the number of years of experience of the project manager handling the project. So we assume that the project manager having more number of years of experience, there is a likely to succeed the project. If he is having less number of years of experience, the probability of the success of that project will be less. So we are taking a sample of 60 projects and the number of years of experience of the project manager and the probability of success is given in this table for 60 projects data. And when we draw this data by using this logistic regression, we can see that we can observe that the probability of success for a given project will be high when there is a greater experience for the project manager, and the probability will be less if the experience is less for the project manager. So that means as there is more number of years of experience, larger the percentage of project success. A perfect relationship represents a perfectly curved rather than a straight line, as was the case in ordinary least square regression. So we need some algebra or mathematics to generate this model. So here we use the logistic function. An explanation of logistic regression begins with an explanation of the logistic function, which always takes the values between 0 and 1. So that means logistic function takes the value between 0 and 1. So the logistic formula are stated in terms of probability that y is equal to 1, which is referred as p. So the probability that y is 0 is referred as 1 minus p. So the relation between this probability and the linear regression can be represented as, so logarithmic of p by 1 minus p is equal to a plus bx. So if you have multiple parameters, then you can extend this linear regression into multiple regression expression like b0 plus b1x1 plus b2x2 up to bnxn plus error term. So here ln represents the natural logarithm, a plus bx represents the regression line, p represents the probability that is to be computed from the regression equation. So if we know the regression equation, we can easily calculate the probability term p from this expression. So probability p can be obtained, p is equal to exponentiation of a plus bx divided by 1 plus exponentiation of a plus bx. Here exp term is called as exponential function. It is also written as e. Consider an example. Let us say we have to model that can predict whether the person is male or female based on the height. Here the parameter is height and we want to predict whether the person is a male or female. Consider the parameter height is 150 centimeters. We want to predict that the person is male or female in this. So assume that we know the intercept and coefficient. A is equal to minus 100. So slope b is equal to 0.6. Using the above linear regression equation, we can calculate the probability of the male given 150 as the height of the person. We substitute these values in this expression. So we get e power a plus bx divided by 1 plus e power a plus bx. So here we are substituting in place of a minus 100. In place of b we are substituting 0.6. Finally we get the probability value y is equal to 0.000046. This is more nearer to 0, so therefore the person is having a less probability of having a male. Probability of being a male. Assumptions in logistic regression. The following assumptions are hold when building a logistic model. There exists a linear relationship between logit function and independent variables. Logistic function is also called as logit function. The dependent variable y must be a categorical and it takes the binary value. That means it may be either 1 or 0. The data meets independent identical criteria and the error term follows a binomial distribution. So generally data is having independent identical distribution. What is meant by independent identical distribution? So each data item is independent of the other data item, but the probability of that data item is same for all the data items. That is meant by independent identical distribution. And the error term is generally binomial distribution, where n is number of records and p is the probability of success. Maximum likelihood estimation. The coefficients in a logistic regression are estimated using maximum likelihood estimation function. First, let us understand what is the meaning of likelihood function before we go for maximum likelihood estimation. Consider a fair coin. What is meant by fair coin? A fair coin outcome will be having equal number of heads and tails for the same number of times. So consider an example. We toss a coin for 10 times. There is a possibility of 5 times head and 5 times tail. This is said to be a fair coin. So equal number of heads and equal number of tails will be the outcome. Let us now discuss about the probability of getting the head. Probability of getting the head is 5 by 10, that is 0.5 in the above case. So if p is greater than 0.5, then we can say that the coin is favor to head. If p is lesser than 0, then we can say that outcome is not favor to head, it is favor to tail. So let us represent n flips of the coin as x1, x2 up to xn. Now xi can take the value of 1 or 0. So 1 means head of the head and 0 is called tail. When we use the Bernoulli distribution, it represents each flip of the coin. Each observation xi is independent and also identically distributed, and the joint distribution simplifies to a product of distribution. So that means the probability of the outcome xi given the parameter theta can be represented as theta power xi into 1 minus theta whole power 1 minus xi. This is according to the Bernoulli distribution for the given outcome xi. The joint probability distribution for these outcomes f of x1 to xn given the parameter theta is equal to, it is written as f of xi for all I1 to n given the parameter theta is equal to theta power xi multiplied by 1 minus theta whole power 1 minus xi. It will go up to theta power xn 1 minus theta whole power 1 minus xn. This is equal to theta power hash h into 1 minus theta whole power n minus hash h. Here hash h is the number of flips that resulted in the expected outcome, that is number of heads in this case. Theta is the parameter. This is how we calculate the joint probability distribution for the outcomes x1 to xn given the parameter theta. Now we will calculate the likelihood equation. The likelihood equation is represented as L of the parameter theta given x, that is equal to, for all I is equal to 1 to n, function of xi given theta. But the likelihood function is not a probability, it will take some value like 0.25 or 0 or 1, something like that. But MLE, that is maximum likelihood estimation, is about the predicting the value for the parameters theta that maximizes the likelihood function. So here our objective is to find out the parameter value theta that maximizes the likelihood function. This is the maximum likelihood function that is used for finding the value of the parameter theta that maximizes the likelihood function. Thank you for watching this video.